Most temples begin with an empty piece. Stone is cut somewhere else, transported to the site, and carefully stacked up, one block at a time. But in Western India, there is a temple that was never built. It was carved out of a mountain. More than 12 centuries ago, workers approached a massive wall of volcanic rock and began cutting down. First, they opened deep trenches on the surface. Then, as thousands of fragments were removed, the shape of a temple slowly emerged. Roofs appeared before rooms. Towers appeared before entrances. Pillars, bridges, stairways, and enormous stone elephants were gradually released from the rock around them. The result is the Kailasa Temple. It is not simply a chamber hidden in. It is a freestanding temple complex surrounded by an open courtyard with nearly every major element carved from a single mass. Today, Kailasa is often presented as evidence of lost machines, forgotten technology, or even help from beyond Earth. But those explanations begin with the mystery is not whether human beings could have. They did. The real mystery is how they planned thousands of irreversible cuts, coordinated generations of skilled workers, and transformed a mountain into architecture without destroying the structure hidden in. To understand how that was possible, we first need to see what they. From outside the entrance, Kailasa does not immediately reveal its true scale. The gateway blocks much of the view. But as you pass through it, the space suddenly. In front of you stands a complete stone temple, rising from the center of an enormous. Behind it is a vertical wall of basalt, roughly 32 meters. The courtyard itself measures approximately 82 meters in length and 46 meters across. But numbers alone cannot explain what makes this place extraordinary. The central temple appears to have been constructed like any other monument. It has multiple levels, a towering sanctuary, pillared halls, stairways, and carefully arranged a separate pavilion facing. Between them is a stone bridge suspended above the courtyard. Along the base, carved elephants seem to bear the temple's weight on their back. Surrounding galleries contain columns, chambers, and sculptures depicting gods, guardians, and scenes from India's great religious epoch. At first, every part appears to be assembled from individual. But look more closely. The walls are not made from stacked. The pillars were not transported. The elephants were never lifted into position. The central tower, the halls, the bridge, and much of the surrounding architecture remained connected to the original mountain while the rock around them was removed. This is why Kailasa is often described as the world's largest single monolithic excavation. It is a building created through every open space represents a stone that. Every surviving column represents material that workers deliberately chose not to. And Kailasa was not created. It stands inside a landscape where generations of builders had already spent centuries learning how to turn volcanic rock into sacred. To understand the temple, we must first understand. Kailasa is known as Cave 16 of the Ellora Caves, located in the modern Indian state of Maharashtra. But the word cave can be misleading. Ellora contains chambers cut deep into the cliff. It also contains monasteries, pillared halls, elaborate facades, and monuments designed to function like buildings in open space. The principal caves extend for more than 2 kilometers along a volcanic escarpment. They were created over several centuries and represent 3 major religious traditions. The southern section contains 12 Buddhist caves. The central group contains Hindu monuments, including Kailasa. Farther north are 5 Jain caves. Their presence in the same landscape. It shows that Kailasa was not the sudden work of an unknown. It emerged from one of the most sophisticated traditions of rock-cut architecture. Generations of craftspeople had already learned how to examine this mountain. The cliff belongs to the Deccan Traps, enormous layers of volcanic basalt formed by ancient. But the rock is not uniform. Some layers are fine-grained and suitable for detailed sculpture. Others contain cavities, weak zones, or natural fractures. The ancient builders understood these. According to the Archaeological Survey of India, they deliberately selected better quality rock for excavation. They also followed natural horizontal and vertical joints to reduce the effort required to split and remove material. This changes the way we should imagine the construction. The mountain was not a featureless block attacked with. It was a material that experienced workers could read. They knew where the stone was likely to separate. They understood which surfaces could hold fine detail and which areas might become unstable. When the Kailasa project began, its builders were surrounded by earlier monuments demonstrating both successful techniques and structural. They did not begin with nothing. They inherited centuries of knowledge. But experience alone does not explain why anyone would attempt a project. For that, we have to look at the empire and the king most closely associated. The main phase of Kailasa is generally attributed to Krishna I, a ruler of the Rashtrakuta Empire during the second half of the 8th century. But the evidence is more complicated than a name carved above the entrance. Kailasa does not preserve a clear dedication identifying every patron, architect, and construction date. Instead, historians combine architectural evidence with inscriptions created during and after the Rashtrakuta period. One important record is a copperplate grant issued several decades later. It praises a magnificent temple built on a hill at Ellora, the historic place associated with Ellora, and connects the monument with a ruler named Krishna I. The description captures the reaction Kailasa was intended to produce. The temple was said to be so remarkable that celestial beings might believe it had appeared by. Even the architect responsible for the work was described as astonished. Amazement, therefore, is not only a modern response. It was already part of Kailasa's reputation close to the time of its construction. However, the monument visible today was probably not completed in one perfectly documented. Differences in architectural and sculptural style suggest that later patrons and generations of artists continued adding to the complex. This is why the frequently repeated claim that the entire temple was completed in exactly 18 years should be treated cautiously. No surviving construction schedule proves that precise figure. It is more reasonable to separate the main excavation from later sculpture, painting, modification. Krishna I may have commissioned the defining form of the temple. But Kailasa, like many monumental religious sites, likely developed. What matters is that the project appears to have followed a coordinated architectural concept from an early stage. The central shrine, surrounding court, separate pavilion, and connecting bridge could not have been positioned independently. Their relationship had to be planned before the rock between them. Kailasa was not simply a sculpture. It was an entire architectural complex designed in reverse. Conventional construction is a foundation is prepared. Blocks are transported to the site, and the building rises one level. If a wall is too low, more stone can. If a block breaks, it may be. Rock-cut architecture works in the opposite direction. It is subtractive. Every decision removes material permanently. Cut too far, and a wall becomes dangerously thin. Misjudge the position of a column, and it cannot be. Remove the wrong section of rock, and a bridge, roof, or upper chamber may disappear. At Kailasa, the builders were not simply hollowing rooms behind a cliff face. They began by cutting downward into the rock, opening deep spaces. That remaining mass would become the principal temple. The excavated areas around it would become the courtyard. The broad construction sequence was probably less mysterious than it first appears. Surveyors and master builders established the major boundaries. Laborers then removed large volumes of stone around the future monument, creating working faces and exposing rough architectural. The tower, roof masses, and upper sections emerged first. As excavation moved downward, workers preserved the rock needed for halls, walls, bridges, pillars, and stairways. Only after the major forms were secure could specialist teams refine the surfaces and add detailed sculpture. The phrase "carved from the top down" is accurate, but it can also be misleading. The workers probably did not complete every tiny ornament at the top before moving to. Bulk excavation, architectural shaping, and detailed carving could occur simultaneously in different parts of the complex. Starting at the top also provided practical. Gravity helped move broken rock. Debris could travel downward instead of being lifted from a deep pit. The height of the main tower. But every meter of progress created. As the original surface disappeared, so did the easiest reference points for the design. The deeper the excavation went, the more difficult it became to keep separate structures. The next challenge was not cutting the stone. It was knowing exactly. Imagine standing on the original surface before the excavation. The courtyard does not exist. The temple walls do not exist. The floor is hidden many meters. Somewhere inside that solid mass of basalt are the future positions of a tower, a pillared hall, a bridge, a separate pavilion, and multiple stairways. Before removing the surrounding stone, the builders had to decide exactly which sections must survive. No complete set of construction drawings has been discovered at Kailasa. This absence is sometimes used to argue that its planning method is unknowable. but a missing drawing is not evident. Indian architects already worked with established systems of geometry, proportion, and temple design. Kailasa also shares important architectural features with constructed temples in southern India. Its designers were not inventing every room and tower. They were translating a familiar architectural language into a completely different construction. Their surveying tools may have been simple. Cords could establish straight lines in consistent intervals. Measuring rods could preserve standard units. Diagonals could test whether a rectangular plan was. A plumb line could transfer a point vertically as workers moved downward. Water could provide a level reference between separate. None of these methods requires modern machinery, but using them across a project this large demanded constant. The builders probably worked from fixed control points that were protected during the excavation. Measurements could be checked repeatedly before another layer of stone was removed. The design also followed a hierarchy. First, preserve the largest masses that must never be lost. Next, establish the tower, halls, pavilion, and courtyard. Then refine walls, roofs, columns, and passages. Only after the main architecture was secure should the most delicate sculpture be completed. This reduced the number of decisions that had to be solved at the same time. It did not eliminate. A small error near the top could grow as excavation. Separate teams could drift away from the central axis. An unexpected fracture could force part of the design to change. Kailasa's survival suggests that measurement was not performed once at the beginning. It was a continuous process of checking, comparing, and correcting. Geometry told the workers where to cut. But geometry alone could not remove a mountain. For that, they needed tools and a detailed understanding of the stone itself. Photographs of Kailasa often focus a sharp corner, a symmetrical pillar, a figure emerging from solid basalt. These images are then followed by a familiar question. How could people create this with primitive tools? The question contains a hidden assumption that simple tools can produce only simple. History repeatedly proves otherwise. By the 8th century, Indian craftspeople possessed established traditions of ironworking, quarrying, and stone sculpture. Their equipment likely included iron points, picks, hammers, wedges, and different types of chisels, shaped architectural detail. Repeated abrasion and finishing refined importance. A single strike from an iron chisel removes only a. At first, that seems to make Kailasa even more impossible. But the temple was not produced by one extraordinary strike. It was produced by ordinary actions repeated with extraordinary consistency. The builders also worked with the geology instead of fighting it blindly. Ellora's basalt was formed through multiple ancient lava. These created layers with different textures and natural horizontal and. The Archaeological Survey of India reports that ancient workers followed these divisions to reduce the labor required for splitting and. This did not make the stone easy. It made the work strategic. Some online theories claim that the builders used lasers or another unknown high-energy cutting device. But no machine, power system, or specialized cutting equipment has been discovered at Kailasa. A device capable of rapidly cutting large quantities of basalt would also be expected to leave physical evidence. Intense thermal damage, melted surfaces, unusual waste, or a wider industrial system capable of powering it. That evidence is. Instead, Kailasa fits within a continuous regional tradition of rock cut. Its rough and unfinished areas. They preserve stages of work that polished photographs often hide. The difference between rough excavation and finished sculpture reveals a slow process of removal, shaping. Kailasa does not demonstrate that ancient builders possessed modern machines. It demonstrates what trained specialists can achieve when technique is multiplied by time. And time was only one part of the equation. To transform millions of individual strikes into one coordinated monument, the builders needed something even more powerful than a machine. They needed an organization. When people hear that Kailasa was made with hand tools, they often imagine a single worker standing in front of an. But Kailasa was not created by one person working at an. It was created by an organization. At the highest level were royal patrons with enough authority and resources to support a long religious project. Master architects established the dimensions, sequence, and major relationships between different parts of the complex. Surveyors maintained reference lines as the excavation moved. Quarry workers removed large volumes. Specialist stonecutters shaped walls, roofs, columns, and stairs. Sculptors transformed prepared surfaces into deities, guardians, animals, and narrative scenes. Other workers cleared debris, repaired tools, carried water, supplied food, and maintained safe access through a constantly changing site. Each group depended on the others. A sculptor could not begin detailed work until quarry teams had exposed a stable surface. Workers below could not remove material until supervisors confirmed that it was not supporting a structure above. Debris crews had to keep working areas clear so excavation could continue. Toolmakers had to repair and sharpen metal points that repeatedly struck hard basalt. This division of labor transformed thousands of small actions into one architect. It also explains why calculations based on one worker and one chisel can be misleading. Even limited daily progress becomes enormous when multiplied across many workers, multiple working faces, and years of the precise amount of rock removed from Kailasa. Online sources often repeat figures of hundreds of thousands of tons, but those estimates vary dramatically. Calculating an exact total would require knowing the original shape of the cliff before excavation. The surviving dimensions are already impressive. More important is the logistical. Every fragment removed from the courtyard had to be broken down, lifted, carried, pushed, or reused somewhere. Temporary paths and working platforms had to change as the excavation deepened. Yet no complete administrative. We do not know the exact workforce, daily schedule, or identities of most people who made Kailasa. The monument survived. The human institution behind it largely, but engineering and organization still do not fully explain. Why would generations of people invest so much labor in transforming one mountain? The answer lies in what Kailasa was designed to represent. Engineering can explain how Kailasa was excavated, but engineering alone cannot explain why anyone would attempt it. The temple is whether dedicated to Shiva, one of the principal deities of Hindu tradition. Its name refers to Mount Kailasa, the sacred mountain understood as the divine home of Shiva. The builders were not simply creating a large stone. They were bringing the idea of a sacred mountain into the human landscape. The visitor's journey begins at the gateway. Beyond it, the central monument stands separated from the surrounding cliff, as though an entire mountain temple has appeared inside the courtyard. Facing the main sanctuary is a pavilion dedicated to Nandi, the bull associated with Shiva. A stone bridge connects major architectural elements above the court. At the base, carved elephants appear to carry the weight of the monument. The architecture transforms religious symbolism into physical experience. One of Kailasa's most celebrated reliefs depicts Ravana, the powerful king from the Ramayana, attempting to shake Mount Kailasa. Below, Ravana strains again. Above him, Shiva remains calm and in. The subject is perfectly matched to the temple. A mountain appears to move, but divine order keeps it stable. And the image itself is carved into a monument that human beings extracted. Other panels depict episodes associated with the Ramayana and these scenes turn the walls into a visual. The temple's meaning unfolds as visitors move through its halls, passages, and courtyard. For a royal patron, a monument of this scale could express devotion, authority, and political legitimacy. It demonstrated the ability to command resources and support religious institutions. For worshippers, Kailasa made a distant sacred landscape physically present. For architects and sculptors, it provided a place where technical knowledge, artistic traditions, and religious ideas could be preserved and expanded. This motivation is often missing from lost technology. Such theories ask only what tools could cut the rock. They rarely ask why people were willing to dedicate so much of their lives to the work. Calling Kailasa impossible may sound like praise, but it can also remove the human beliefs that made the achievement possible. The final question is therefore not whether the temple required supernatural tech. It is which parts of its creation we can genuinely explain and which parts. The strongest explanation for Kailasa does not depend on one secret tool. It depends on a chain of understandable. The builders selected workable basalt in a landscape already famous for rock excavation. They studied the natural layers and fractures of the stone. They established the main geometry before removing material that could never be. They excavated downward, allowing gravity to help move debris away from the upper working area. They divided the project between surveyors, quarry workers, architectural carvers, sculptors, and support. And they worked within an established tradition of temple design. Each step was possible. Together, those steps produced something. But important questions remain. We do not know the exact duration of every construction phase. We do not know the precise number of people involved. No complete set of architectural drawings has survived. We cannot reconstruct every temporary ramp, platform, or path used to remove stone. We also cannot identify most of the craftspeople whose decisions are preserved. These gaps are not proof of. They are reminders that stone preserves some kind. Stone preserves dimension. It preserves tool marks, unfinished surfaces, fractures, and changes in artistic style. But it rarely preserves instructions, conversations, or daily schedules. The most useful question is therefore not, could ancient people have created this? They did. The better questions are more precise. How did architects maintain alignment as the original cliff disappeared? How was knowledge shared between teams working at different levels? What happened when workers encountered weak or fractured? How did royal authority sustain such a demanding project? Those questions do not reduce the mystery. They transform wonder into an. Kailasa Temple does not stand outside human history. It stands at the meeting point of geology, religious imagination, political power, architectural tradition, and organized skill. Its tools may appear simple. Its system was not. Perhaps that is why Kailasa still feels important. We can see the finished monument, but the organization that created it has vanished. What remains is a mountain transformed into its opposite: open space, movement, architecture, and story. The mystery of Kailasa is not that an unknown civilization possessed technology beyond human understanding. It is that human beings, using knowledge we too easily underestimate, created something that still exceeds our expectations of. And that may be the more astonishing. If you want to investigate more ancient structures where the evidence is even stranger than the legend, subscribe and join us for